Right, so we saw that the ps command lists the currently running processes and their process IDs. That's useful to find out what to kill if you had to if you wanted to stop a program from running. Use kill, and then you had to find the process ID. And of course, the process ID will change every time you run that command. If you run it now, if you run ls, if you run sleep now, let's try that. Sleep 10. Oh, here's an easy way to check all of this. Grep sleep, and have this running in the background. Here's an easier way. Have that running in the background and then do a PS and grep for sleep. Let's try that. Oh, it worked. So what this did was it ran sleep in the background, and then once it was started, we run PS right away without waiting for sleep to finish and search for sleep, and there it is. And we get this. Here's whenever you run something in the background, it prints out the process ID, and then sure enough, when you run PS, you get the exact same process ID. Good. Everything works. Okay, so this is done. So now we can try this with a longer time period, 50 seconds. We know the process ID, so we can kill it. 4447. And we see that it was terminated. So one thing to note here is that when you run sleep over here, the process ID was 4443. You run it again with a different number, of course, or you can run it again with the exact same number. And what you will get is a different process ID, because that's a brand new instance of that program that's running now. So if I hit return, there is a brand new number. This time around it's 4450. Okay, you see it's going up in sequence, so it basically goes from 0 or 1 to as high as it can go. Okay. So usually this is used with the process ID of the process to be stopped. That's what we did. We said kill, and then we found out the process ID, and then put in the process ID, and sure enough, that process stopped. Of course, you can't kill anything, because then you could kill all of the stuff that belongs to Linux, all of the core utilities, and which Linux needs to run. So the rule is that you only can kill things that you have permission to kill. That is, so you only can kill things that you own. So if you're the owner of a process, you can send it the kill signal. So what kill is really doing is actually, even though it's worded to make it sound like kill stops a process, what it really does is send a signal to a running program. And why would you want to do this? We use sleep, but sometimes a program can get into an infinite loop, or it might wait indefinitely for something to happen, such as wait for a file to be available or a network connection to start up. And sometimes you might know that it's just not going to happen. It will just sit there, so it's best to stop that process from running, and that's usually when you use kill. Alright, so next let's look at this T command. T works like a T-splitter in plumbing, and you can click on this link if you have the notes. It'll take you to a Wikipedia article. And in plumbing, what you do is you send one stream of water in two directions, and that's basically the same idea for the command. We send one stream of, let's say, output to two directions. One is the standard out, and the other would be a file. So here's a simple way of using T. Ordinarily, ls-la will send the output to the file, to a screen. But if you want to record the output of a command to a file and see the output on the screen, you would do something like this. Let's try that. ls-la, that's long options and all, including hidden files. And use the T command this does is we're using the pipe operator to send the output of ls into the t command. So the output of ls becomes the input of t, and t sends it in two directions. One is to the file, the other is to the output, standard output. Okay, so we see the output here. Also, if you were to cat file list, you'll see exactly the same thing. So let's say we did something like this, ls minus la, and we did a word count minus l. So remember, word count minus l counts the number of lines, so effectively we're counting the number of files. And there's 44. And t is often used as a way to debug piped commands. So if you have a long list of files, you can do this. So what have we done? We're taking the output of ls, sending it to t, where t will send it to a file and also to standard out, but then we can, instead of seeing it on the screen, we can pipe the output to word count. So it's just like what we had before, except we're saving whatever's going into the pipe into a file now and sending the output of that t command onto this other command. So it's just like inserting a tap here to see what's being sent from one command to another using this pipe. So you can see the plumbing metaphor. The T is just a way to sort of get a tap, get a peek at what's being sent through the pipe. So notice that the output is exactly the same as before. Right, this command, these two commands produce the same output, and there was a reason for that because we already had this file list. If we didn't have this file list, actually this would change a little bit. It might go up from being 43 here to 44, but this file list was already created. You can cat it, and you can check the time of file list and see that it was just created. Okay, so there's a number of options for T. So you can say T in file name, or you can say specify a number of options. A will append rather than overriding the file list. Overriding the output file. In this case, file list. Okay. Next up, let's take a look at startup files. So when a shell starts, it looks in two places. It looks in the system profile and then the user profile. It loads this first, and so typically it goes to /etc/profile and takes a look at what commands it needs to execute. By default, it executes things like the date, and in our case, these things don't happen, but when you log into the server, you will see stuff like this. You'll see a message of the day, things like that. So if we were to cd or ls/etc/ see if there is a profile, a file called profile. Sure enough, there is one. If you were to cat you'll see a bunch of things, and you will see script files will actually look a lot like this. You will see if statements, so it's a little bit more complicated than we want to get into right now, so we won't look at this a whole lot, except to note that this is a system-wide .profile file for the Bourne shell, that is bash, and Bourne compatible shells. And take a look at this. You might want to just explore on your own, because we will be setting up statements like this with if statements, else statements. Those things happen in the next set of lectures. Okay, so we'll take a look at those kinds of things later. If you say ls-a, what you will see is that there is a local or user profile, and you can use this to customize the behavior of the shell. Let's see what's in there. And here there's just more if statements. And so, since we haven't really talked about if statements, let's just ignore this and look at it once we've gone through shell scripts. There's a number of other files you might have noticed. If you say ls-a, there is two things you want to look at are the bash rc resource file. So if you recap that, see more stuff like that we saw before. But one of the things you might want to note is that there's a bunch of aliases. So for example, in your bash rc, which is run every time bash starts up, there's an alias that says, if you type in the command L, it's just an alias for ls-cf. What does that mean? So here's ls-cf, and if you type in L, you get almost the same thing. Let me just check. Oh, uppercase F. Okay, so ls-cf gives you this. If you type in L, you get exactly the same thing. So L by itself is an alias for ls with the options -cf. Once again, when bash starts up, these system-wide options are run, and in the case of the example in the book, that's very simple, but as we saw on our live DVD, it's a much more complicated file with if statements and things like that. Similar thing for the user profile. So this gets run for everyone, but your local .profile file will have custom things just for you as the user. Okay, so as we saw, if you run the env command, you'll see a whole bunch of shell variables. Most systems and users will have environment variables defined, and typically more than one shell will use the same variable. For example, $home is used by all the shells, but some variables are not used by things other than bash, because we set it up for bash mainly, but not all other shells will use it. If you want a reminder, all you have to do is type in the env command, and you will see a list of all of the shell variables that you currently have defined. There's a bunch of options. There's not much of a chance that we can go through all of them, but one thing that you want to look at is the noclobber option. This is used to prevent a user from overwriting existing files. So by default it is not enabled, but if you do want to enable it, you have to use the set command, set -o noclobber. Let me see if that works. So when is this used? This is used when, let's say you do something like ls, pipe the output to output. And now you have an output file which was created at 8:06. If you run the output ls-l, run the file, what you will have done is you will have clobbered that file, so that you replaced that old output which had 145 characters with a new one. Since we used -l, we got a bigger file with 836 characters, made about a minute later. If you use set -o noclobber and try to clobber the file again, you'll get an error message saying output cannot overwrite existing file. So that's the use of noclobber.